Okay, this time we will do this question balanced binary tree. So to do this question, you first need to know what is a height balanced binary tree. So see this height balanced binary tree is a binary tree in which the depth of two subtrees of every node never differs by more than one. Means the depth of both the nodes, the depth of both the subtrees will never differ by more than one. This means, see, I'm explaining with you with this example. See this. This if you see this 20th node, okay, this 20, the left depth is 1, okay, this right depth is also 1. So 1 minus 1 is 0. It is less than 1. Yes, again it is less than 1. It is 0. Yes, and now if I tell you, if you go to this node, this 3 node, okay, just focus on this node. Focus on this node first. This 3 node. The left depth is 1. Yes, and the right depth is the right depth is 3. Yes, or I can say 2. Yes, consider these two. This depth is 2, this depth is 1. If I minus 1 minus 2 is minus 1, but we will take mod of it. Okay, we will take absolute value of it, and this gives us 1. 1 minus 2 is 1 only. Yes, now see this. So this is a balanced binary tree, and that's what given here. See, this is a balanced binary tree, output is true, that's why. Okay, so if you go to this node, see, if you go to this node, check here. The left depth is 1 minus 1, and take the mod of both side. Take the mod of both side. If you take the mod, this will give you 1 minus 1 0. So yes, it is a balanced binary tree. Go to this node then. Okay, this 2 node. Okay, and if you go to this 2 node, the left depth is 2. Yes, it is 2 minus. Wait, let me take mod first. 2 minus the right depth is 1. Yes, it is 1. So we'll do like this. Oh, not this bracket. Yes. So this is also a balanced binary tree. Why? Because 2 minus 1 is 1. Yes, perfect. So till here our tree is balanced. Till here our tree is balanced. But if you go to this first node, this node, the left depth is 3. Yes, 3 minus the right depth. Right depth is 1 only. So if you do this, this will give you 2. Now it is more than 1. Yes, that's what I was saying. It will never be more than 1. If it is more than 1, then it means our tree is not balanced yet. Okay. And if our tree is not balanced, we just have to return false. Anytime our tree is not balanced, we have to change our output to false and we have to return it. Yes. So a very easy question again. But applying recursion is like if you have done that maximum depth question of binary tree, then applying recursion here is also not a big deal. So see, whenever you will go to this node, means your left is also null, your right is also null. Yes, they will return you 0. Yes, they will return you what? 0. So yes, they are returning me 0, and I will check difference of their depth. So the difference of their depth, 0 minus 0 is again 0. So this is a perfect node, means this node is balanced. Again, this node will also be balanced because its left and right are also null. They will return me 0, and I'll check 0 minus 0 is less than 0. So again, this is also a perfect node, and then I will return its depth. How will calculate its depth? So see, both the nodes are 0. So we will take math.max of both the nodes. It is 0 plus 1. So its depth will be 1. Depth of this will be 1. Yes, and depth of this will also be 1. Then we will come to this 20th node. Okay, and we will do 1 minus 1, which will give us 0. So means it is a balanced node. This 20th node is balanced. Then we will do what? After that we will calculate its depth. Its depth will be what? Math.max, both of them. Which is max here? Both are 1 1. So we'll take 1 and we will add 1 by ourselves. So it is 2. Depth of this is 2 and this is 1. Again we will check, is this a balanced node? 1 minus 2 is, again if we take mod, it's 1 only. So yes, this is a balanced binary tree. So if it is a balanced binary tree, so what we will do then? So if it is a balanced binary tree, we just have to return depth to its depth is what? 3 right now, and now depth is not really required. So let me write the function of it. It's easy. If you see this recursion code, you will understand this. Let me use this type of function. The old way of writing function in JavaScript. Yes, function. Let's name it traverse. Yes, I like this name traversing. Yes, that's why I always name it traverse. Traverse and current. Okay. So now I will call this function with, I will call this traverse with what? I'm calling it with root. Yes, I'm calling it with root. See, I'm calling this function with root. And now what I will do? I will see. I'll create an answer first, which is true right now. Let ans is equals to what? True. Yes. Okay. 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 Yes. It's true. Right now it is true. At last, I will return my answer. Yes. Return ANS. Yes. Perfect. So at last I will return. But here our logic, our code logic is here only. How I'll write it? I will go to bottom first. So how to go to bottom? Let left is equals to left bottom is traverse current dot left. Yes. Perfect. And let right is equals to traverse current dot right. Perfect. Again. So see, whenever this traverse function will run, this traverse function will first run with this 20. Then inside that 20, this will run with 7. And inside the 7, this will run with null first. So whenever my current node is null, if my null of current node means my current node is null, then just return 0 from that. Okay, just return 0. I'm returning 0 from that. Return 0. Perfect. So at last node, when this function will call for 7, this function will be called for 7. This function will return me 0. Yes, this will return me 0, and then it will call that same function for 7 dot right. Then again it will return me 0. Yes. Okay, okay, okay. Not 7. See this example. We are going to left here. So here I'm going right and I'm telling you for it left. So suppose it is going for 9. Okay. Then suppose this function is called for 9 first. See, 3 dot left. Current is right now 3. 3 dot left is 9. This function will be called for 9. Inside that 9, this function will be called for null once. Okay, null for first time. When it will be called for null. Left will be 0. Okay, understanding is a little bit tough, but it's not that tough if you have done previous questions. So then this will call function with current dot right. Current is 9. 9 dot right is null. Okay, 9 dot right is null. 9 dot left is also null. So this will return me 0. That's why my left will give 0. And then this will be called with 9 dot right. That is also null. This will also return me 0. Yes, this will also return me 0. So both will give me 0. Then I will check, is this a balanced node? Means I will check for each node, is this a balanced node? So if math dot abs left, wait, left minus right is greater than, okay, is less than 1, or less than equal to, suppose it is greater than 1, is greater than 1, I will change my ans to false. Yes, if any time that happens, I will change my ans to false, and then I will do what? I will just return its depth to its parent. Yes, return its depth to its parent. Math dot max left comma right. That's how we calculate depth. Yes. So see, this 9 will be called for both null. We will have 0. Right now this code will not run because left minus right is less than 1. So it will return its depth. Left and right both are 0. So depth will be written as 1. 1 will be depth. And 3 dot left, inside 3 this left is will be 1. Okay. Then this will call for 3 dot right. Then this will be called. Then this will be called for 20, and like that recursion bugs. So if I submit this, this will be submitted. I know this. See, this will be accepted. I know that. Let me wait. Okay, so yeah, and if I submit this, this will be submitted. That's very easy code. Okay, so accepted or not? Oh, okay, accepted, and it is running in 1 millisecond. So that was my solution for this, and that was an easy solution, I would say, because applying recursion here is not that tough if you focus on if you have done that maximum that question. So thank you so much. That was my code for this. Thank you.